Welcome to The Explainer, where we break down big ideas. Today, we're diving into a really clever system NASA uses to handle unbelievable amounts of risk. It's called the Technology Readiness Level scale.
I mean, really think about that. That's the huge, high-stakes question that organizations like NASA have to answer for every single mission. When you're literally inventing the future, how do you make sure you don't end up with $1 billion paperweight? Or worse?
To get a handle on this, NASA knew they needed a system, a standard way to figure out how mature a new piece of technology really was. They needed a tool to manage all the risks, not just technical, but cost and schedule risks too.
And this is what they came up with, the Technology Readiness Level, or TRL scale. The best way to think about it is like a universal ruler for innovation. It's a way for an engineer, a project manager, and a scientist to all be on the exact same page about how ready a piece of tech actually is.
Okay, so let's actually climb this ladder and see how you get from a simple idea all the way to orbit.
You can basically break down all 9 levels into 3 big stages. First up, you've got the research phase. That's TRLs 1 through 3. Then you move into focused development, which covers levels 4 to 6. And finally, you have the demonstration phase, levels 7, 8, and 9, where the technology has to prove it can survive in the real world.
And here it is, the whole shebang, all 9 rungs of the ladder. You can see how a technology has to methodically climb each one, proving itself at every single stage. It's a long journey, from just being a concept on paper to being a fully tested system in the unforgiving environment of space.
So every single piece of new tech, no matter how revolutionary, it all begins right here at level 1. This is the absolute bottom, where scientists are just starting to translate basic research into a potential application. It could be as simple as observing the properties of a new alloy in a lab.
And what's so cool is that with every single step you take up this ladder, the risk goes down and the confidence goes way up. For instance, going from what they call a breadboard in the lab at TRL4, which is kind of like a rough draft of a circuit, to a really solid prototype being tested in a realistic setting at TRL6, well, that gives everyone a whole lot more faith that this thing is actually going to work.
Okay, so that's the theory. But how does this ladder actually connect to the nuts and bolts of launching a real mission? Well, let's take a look at how it's woven directly into the project lifecycle.
See, the TRL scale isn't just some helpful guideline. It is literally baked into the DNA of a NASA project. You can see how the TRLs on the right line up perfectly with the major project phases. It acts like a gatekeeper at these super critical decision points and design reviews.
Now, out of all 9 levels on that ladder, I want you to focus on just one number, 6. In this entire process, you could argue that TRL 6 is the most important milestone of them all.
Here's the deal. A critical piece of technology absolutely must prove that it has hit TRL 6 before a project can get the green light to move into the final, super expensive design and fabrication phase. That means it has to be fully demonstrated in a relevant environment, whether that's on the ground or in space.
And we're not just talking about a technical check-in here. This is a massive financial and strategic commitment. Passing that TRL 6 review means the technology is officially mature enough to be designed into the final mission. If it fails, that could mean huge delays, big cost overruns, or even having to scrap it and find a whole new solution.
But, as powerful and as essential as the TRL scale is, it's not a silver bullet. It's not perfect, and it's really important to understand its limitations.
On one hand, the advantages are massive. You get a common language, way better risk management, and much clearer decisions about funding. But on the other hand, it's got a huge blind spot. Just because a technology is ready doesn't automatically mean it's the right choice for a mission or that it's going to play nice with all the other systems.
And maybe the biggest gap of all is this. The scale is fantastic at telling you if the tech itself works, but it says almost nothing about how it works with the most complicated system on any mission, people. I mean, just think about this for a second. You could have a system that is a perfect TRL 9. It's been flight-proven, it works flawlessly, but it could be totally unusable for the astronaut who needs to operate it under incredible stress. That highlights a massive, potentially mission-threatening gap that the scale just can't measure, the human factor. So that kind of leaves us with this big, lingering question, doesn't it? We've got this amazing 9-step ladder to prove that a machine is ready for space, but what kind of ladder do we need to prove that the human and the machine are ready to work together as a team?